Okay, so with this question, we were asked to prove that all these brackets on the left-hand side over here will all simplify to just give x over 3. So I'm going to do lots of factorising here. So first, let me just focus on this the x squared minus x minus 6. So if I factorise that, I'm going to get x minus 3 x plus 2, because the minus 3 times by the 2 will give the minus 6, and the minus 3 plus the 2 will give the minus 1. So that is the yellow highlighted, that is that factorised. Now let me factorise the green quadratic there. So that's going to give, oops, let me use the right pen, that's going to give x minus 4 x plus 1, because the minus 4 times the 1 will give minus 4, and the minus 4 plus 1 will give the minus 3. So that is the green highlighted part. Now the red, let's factorise that. Well, that's a simpler one for me to factorise because that just has an x as a common factor of the x squared. Oops. And x is the common factor of the x squared and the 5x. So taking the x outside of here and here will just give x times x plus 5. So that's everything factorised on the numerator. Now let's move to the denominator. So let's now look at this. Let's factorise that. So that's going to give me x minus 4 x plus 2, because the minus 4 times 2 will give me the minus 8, and the minus 4 plus 2 will give me the minus 2. Next, running out of colours here, let's factorise this one. So if I factorise that, I'm going to get x plus 5 and a x minus 3, because the 5 times the minus 3 will give me the minus 15, and the 5 plus the minus 3 will give me the plus 2. And then the very last one, if I factorise that, if I factorise this, I'm going to, the only common factor of 3x and 3 is just 3. So I'll factorise the 3 outside and I'll get an x plus 1 on the inside. Now we take a deep breath because we've finished all the factorising. Next comes the fun part, in that we get to do all the cancellation. So I can see that I've got an x minus 3 here, and on the denominator I've got an x minus 3 here. So they are going to cancel out. Then I can see that I have got an x plus 2 here, and I've also got an x plus 2 on the denominator here. So they're going to cancel out. Next, I've got this x minus 4, and on the denominator I've got an x minus 4 there, so they're going to cancel. Then next I've got an x plus 1, and I've also got an x plus 1 there, so they're going to cancel. Next I've got this x. Now there aren't any x terms on the denominator, so that is not going to cancel out. And finally I've got this x plus 5 here, and I do have an x plus 5 on the denominator, so they're going to cancel out. And so therefore the only two terms that are left is the x that's on the numerator and the 3 that's on the denominator. So my final answer then is x over 3, which is good because that's what I wanted to prove.